Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be producing what you see on the screen, which is of course a bubbling cauldron. In order to achieve this, we're going to be using thinking particles, and we're also going to be using what we've got in a subdivision surface over here. I've got a plane, I've got a collision deformer, a jiggle, and also a smoothing deformer, and they're going to play a key role in making this thing work. That's what we're going to be about in this tutorial, so without further ado, let's see if we can make this happen. At first glance, it might be tempting to bring a disc in and use this as the actual simulated fluid. Not a good idea, because triangles are the problem here. We can see that we've got triangles. So we don't want to use a disc. We want to be able to produce a round object that's made from quadrangles. And the way I'm going to do that is to bring in a flat plane. 400 by 400 in the width and the height is fine. I'm not doing this to any particular scale. You can if you wish to. But what I will do is make this 200 by 200 in the width and height segments. Now, 200 is just for the demonstration that I'm doing here. If you put this together as a final model, it's best to use 400 by 400 because that gives you a really good sweet spot for this. That's what I found anyway when doing mine. But in order to speed the timeline up a bit when we run the animation, I'll do it at 200 by 200. So I've got a plane. The next thing I need is a cylinder. We'll bring one of those in. We'll make its radius 75. The height can stay at 200, that doesn't really matter. We'll make one height segment and 60 rotation segments. Okay, so we've got two elements ready to go. The next thing to do is to make both of these editable, and then we'll drop them into a bool. So let's get a bool, hold down the Command and Option keys, grab a hold of a bool, and they're both in there. Now at the moment it's not set up correctly. Let's see what we need to do. A union B is no good. It's actually A intersect B. That's what we need, and that gives us a nice flat plane, and we can see that it's made of quadrangles. So that's perfect. That's what we need. What I'll do is copy this and make this one invisible, so that if we do make any mistakes, which we shouldn't do, but if we do, we've always got that one ready to go. We can then select the bool, hit C to make it editable, and all we need to do is remove the cylinder, remove the plane from the bool, and then delete the bool itself. So that's it. We've got our flat plane now, and it's set up as we need it to be to give us the result that we want. Fantastic. So we can move on from here and start the next step. The next thing I'm going to do is bring in a sphere. It's way too big. I just need it to be 10, and I'll give it 24 segments. And this is going to form the basis for our bubbles. So we can just move it down. Just leave it beneath there. That's fine. Moving on from here, we can add a null. We can call it Expresso. Give it the Expresso tag. We've got the editor open, and we're ready to start work. The first thing I'm going to do is bring in a time node. So in my general menu, select time, and I won't be changing anything here on this occasion. Normally I do delete the time port, but on this occasion I need it, so we can leave that exactly as it is. The next step is to open the system presets over here, general presets, and in here we've got a random integer. We'll bring one of those in, and at the input stage give it a time port, which is here, and then we can connect these two. So that's the next step done. Now, the parameters for our random integer here are set up pretty much as we need them to be. I do want a lower limit of 0, an upper limit of 3. The random seed, you can place any number in there that you choose. I'll just leave it at 1. That'll be fine. And then the next step from here is to bring in a compare. So we'll bring in a logic compare, and we can connect the integer output port to input 1. and it's set up exactly as it needs to be. Again, this equal to 0, exactly what I want. So when we generate a random number that's 0, we will get a true output from our compare, and that's exactly what I want, because I'm going to be using this as a switch, and you'll see what I'm going to do with that in a minute. But anyway, that's our first 3 nodes taken care of. We can now think about bringing in some more nodes in order to get the thinking particles started. The next thing to do is select the Expresso here. Now I'm going to be using this as a source for my thinking particles. You'll see how that's going to work very shortly. The first thing though that I need to do is make this value here, so the rotation P, 90, so that we're facing along, or I should say, so that the z-axis is facing upwards. And I'm going to move it -20. Okay, so that's got that set where it needs to be. The next thing to do is drag it into the editor window, and then we can start to think about what we're going to do with it. Now at the output stage I need global position, and I also need global matrix, so we've got both of those in there. And these are going to control basically the rotation and position of our thinking particles emitter. That's what they're going to be used for. The next thing to do is bring in the first of our thinking particles nodes. So thinking particles, we want a generator, and it needs to be a P storm. At the moment there's not much going on, so we've got an emitter position that will be connected here, and we can see that we've got a big circle here, this big white circle, that's going to be the emitter. So we've got to do some work in order to orientate this correctly. So the next thing we need to do is select emitter alignment, and we can connect our global matrix to that. Okay, so those two are now done, and if we just play, we can see that instantly our emitter flips around to match up with our Expresso null here, and we're already starting to generate some particles. So it's working so far. The next thing we need to do is give this an on port, and this is where we're going to connect the compare. So we don't want particles to be generated all the time. I don't want them at every frame. I want them only when this integer or random integer generates a 0, and that's why we've set that up. So we can plumb that in there. So that's the next thing that we've done, and if we play now, we can see that it's flickering. So it's only producing particles at the correct time now, just when that 0 is generated. So that staggers things slightly, and that's what I want it to do. Fantastic. So let's move on from here. I'll add a couple more ports at the input stage, which we'll be using a little bit later on. So I want a size port, and I also want count. So there are our inputs all set up. At the output stage, particle birth. And that's the node set up with all its ports. Now let's have a look at the parameters. The type is fine, that's circle. The birth type is count, that's absolutely fine. Now we're going to be taking control of the count here a little bit later, so the 100 here we can ignore. The life I'm going to make 40, and I'm also going to give it a variation of 20%. We'll leave the speed at 100, that's fine, and make this 50% with the variation. We're going to be taking control of the size, so we'll ignore that, but we will give the size variation 50%. Now the XFOV and YFOV, that's the angle at which these particles are spitting off. You can see that they're spitting off at up to a 45-degree angle. We don't want that, we want them to be 0, so we'll 0 those two out. And if we play now, we hopefully, yeah, we can see we're starting to get them. They're just coming straight up, traveling straight out. That's exactly what we want. Fantastic, so we've got it that far. The X and Y sizes, we just need to make these 120 and 120, just to make our circle or our emitter just that little bit bigger. and everything else we can ignore. We don't need to touch anything else. So they're the basic settings for our particle storm. Moving on from here, we can bring in a couple more nodes. We'll bring in, where are we? Thinking particles. We want a P-shape node, so that's in our standard menu here. So we've got a P-shape, we'll bring that in. And that just needs to be connected to the particle birth. And then in our object parameter here, we can just drag in the sphere, and we'll set the bounding radius to 10. So that's our P-shape. That's going to give us our sphere as the shape of our particles ultimately. In fact, what we will do with this sphere is make it into a hemisphere. That's what it really should be, because obviously these are supposed to look like bubbles, so they don't need to be a full sphere. But anyway, that's done. So we've got the P-shape in. The next thing we'll bring in will be a P-group. So again, a standard menu here, P-group. Bring one of those in. Connect the particle birth to that too. And we've got nothing in our parameter here. It does say all in here, but to make sure that everything is correct, what I'll do in my simulate menu, come to my thinking particles settings and drag this all into here, just to make sure that everything is correct. Okay, and force this setting I've got on show objects. I'll leave that as it is, and show object in here, I'll leave that too. Okay, so we've got things that far, and we're well and truly on the way to getting what we want. We're not there yet. We've still got some work to do, but we're well and truly on the road. Right, moving on from this step, what we need to do, I'm just going to make this smaller. I'll just take it, wrong one. Wrong window, not the one that I wanted to do. I wanted to get rid of the editor, so just get rid of that one for a minute. What I want to do, you can see that the particles are being emitted, and as it stands, they're actually going through the flat plane that we've got here. Now, what I want them to do is emit, rise, and once they're level with the plane, come to a standstill. And then I want them to basically start as very small spheres and then expand, okay, so that they actually behave like bubbles. We're going to do that by using Expresso. So we'll just bring this back, just adjust that window so that we can see where we are again. Okay, so what are we going to do? Well, for a start, we need to bring in another thinking particles node, and that will be a P-pass. So it's a TP initiator, P-pass. And that, again, has got all in here. Let's just go and make sure that we get that set up. I mean, I know I'm being pedantic with this. I probably don't even need to do it, but I just prefer to do this correctly. So let's just drop that in there. Okay, so I've got that in my P-pass and it's ready to go. Now the data that we're interested in is going to be the position. So we need a get data. So let's bring one of those in. Let's see where we are. We need, it's a helper, I think. Or is it, where are we? Get data. Where is P get data? There it is in the helpers. P get data, okay, that's what we need. We can plumb that in there. And the data we're interested in is the position data. So we're going to bring that into there. So our particles, we're going to get the position on them. And we're obviously, it is all the particles that we're interested in, because we're not using groups. We're just using a group with everything in it. Okay, fantastic. So we've got it that far. The next thing that we need is a vector to reals adapter. So we'll bring one of those in and plumb our position into the input. Now, what we're interested in is the position Y, because obviously these are rising upwards. So our X and our Z we can completely ignore. What we'll do is bring in another adapter, reals to vector, place it over here, and then we can plumb the X into the X and the Z into the Z. Just make this a little bigger now because we're getting a fair few nodes in there. We then need a compare again, so we'll grab a hold of this one, command drag to copy, bring this in here. Now this compare, we need to change the function to greater than or equal to, And again, we can say 0. So we'll grab a hold of our Y output from the vector to reals here and plumb that into here, into our input 1 of our compare. So as soon as our particles reach a 0 along their y-axis, which will be perfectly level with our plane, because if we select that and we look at the coordinates, we can see that the position y is 0. So as soon as our particles are literally level with our plane, we want them to stop. That's what we're going to be doing. So let's get a condition node. We'll get one of those. Logic condition. Place this just in here. So as soon as our compare output is true, we can switch here. And what we're going to do then is hold the particles at 0. So our input 3 we can leave at 0 because that's the value we're going to want. Until that condition is satisfied, we can plumb our y-axis of our vector to reals node, which will of course give us the position y of each point, and we can plumb that into the input 2 of our condition node. So as long as our condition isn't satisfied, we just want our particles to keep rising, and that's what this will allow us to do. And then we can simply plumb that into there, and that will give us the situation that we want. So all the time our particles are less than 0, they're allowed to keep on rising. As soon as they hit 0, this will be switched, output 0, and they're held in that 0 position. That's what's going to happen. So in order to make this all hang together, we need another node from our thinking particles menu. And this will be a set data. Now let's have a look and see where we are. Now our set data is not where you'd expect it to be. We've got get data here. You'd think set data would be in there, but no, it's in here. So it's in the standard menu. So P set data. That's the one that we want. So our particle we can set from our P pass. So we get that from there. So that's our particles. And then we once again we need to say position. And just open this up, and then we can plumb that in there. Right, so let's see if this is actually working. Let's just move this out of the way and see if anything works. And straight away you can see that it does. Our particles are literally sticking to the flat plane. And that's exactly what we need them to do. So that's all working, and everything in the cauldron is lovely. Fantastic. Before we finalise the Expresso, the next thing to do is to create some user data on a null. So we'll just close this window for now, bring in a null, call it controller, and we'll add some user data. We'll create a group, pull it away from the user data, call it controls, and we'll bring our first data into there. We'll call this particle count. It will be a float data type, a float slider for the interface, a real value, steps of 1 perfectly fine, and values between 10 and 50. You can change these values if you wish, but they're the ones that I'm going to go with, and we'll leave it at 10 as the default. Add some more data. This will be particle size. Once again, a float for the data type, the interface a float slider, and the unit a real value. And on this occasion, I'm going to use values between 2 and 10. And again, I'll clamp those values. We'll start with 2 as the default. And lastly, we'll add some more data. This will be called ripple size. Let's just make sure I spell ripple correctly. Ripple size. Again, a float data type, float slider interface, a real value for the step, or rather the unit, and the step value of 1. And values this time between 20 and 30. And I'll clamp those two. And that gives me my user data, so I can say OK. And we've got those there. We'll just move them to get rid of the orange bars because that will cause problems. Okay, so that's all set up and ready to go, and we can think about moving back to the Expresso and completing things there. So let's open the Expresso editor once again, and we can think about bringing some more nodes into here. There's not much more to do actually. Let's just bring the controller in for a start. So we've got that there. And in our controls, we want literally everything. So count, particle size. I'll bring the ripple size in. We can't do that yet. That's going to be the final step, and we can't absolutely do that until we get our deformer that we're going to be working with into our scene. So that will be the very final step. But we've got the particle count and the particle size. Now the count can be plumbed straight into here. So that's going to be taking control of our number of particles based upon what we've got here. Okay, so that's going to be 10 at the moment. Now our particle size we can also plumb in to here. We'll do that first. Just leave that in there. But next we now need to actually bring in a p-size node. So once again we'll come down to our thinking particles here, and in our standard menu we've got a p-size, so we'll bring that in and we'll give it a size port because that's what we're interested in. We can leave that down there, and our particles here, once again from our node here, we can just bring that into there, and our size will be controlled once again by our particle size. So that's going to be brought in there. Now, something very important, we're going to actually be doing this over age. Okay, so that's going to be important. We're going to set all this up in here. That's going to be our next step. I'll check over age and set up the variation. I'm going to use an 80% variation in there. Now, this down here, let's see what we can do. For a start, we need to change the color of our knots. What we'll do, I will invert the gradient because I do need to start with a black knot. It needs to be at 0, so that's fine. Our second knot here we need to place at 55%. Our bias we want set to 99% on our, so that's not the right one, it's this one that I'm interested in. Make that 99%. That's it, that's what I want there. So that's where it needs to be. And knot here, what I can do here is set this one to 90%. And once again, this can be obviously 100% brightness. I'm not going to change that. And the bias can be left at 50. What I will do is command drag this knot over to here, and the only thing I need to change then is the bias of this knot, and that needs to be set to 4%. Now what's going to happen here, our particles are going to rise just about at the point where they touch our plane. They can then, they will be growing to a degree because obviously we start with them basically tiny or more or less non-existent, and then they'll gradually grow until when they reach here, and at this point they're going to stay at their maximum size, and they're going to be held at their maximum size, and then they'll pop, so they'll just disappear and fade away. That's what's going to happen. That's why I've done this over age. So that's the idea, and that's set up and ready to go. The next step is to bring in a TP geometry, and we get that from the Thinking Particles menu. So we bring one of those in. We can just drop that above the Expresso, and it needs a particle group, so we'll go back into our Thinking Particles settings and grab a hold of all and drop that there. Okay, so that's set up and ready to go. Moving on from here, we will need to think about adding the deformers to our plane. We'll start by bringing in a collision deformer. So we'll hold down our shift key with the plane selected and bring in a collision deformer, and that's now in there. Under our object tab here, we need to start thinking about what we're going to do. Now the fall off, we need to set that to collider. Our distance we can ignore because we're going to be taking control of that via this ripple size here. So we'll ignore the collision, or rather the distance I should say. The strength, we only want 20%, so we'll make that quite low. The restore shape we'll leave at 100%, and then we can worry about our curve. Now this needs to be a damp sine wave, so we'll start from somewhere around here. It doesn't have to be exact, I mean you can adjust this to your own taste, but we'll bring in another point down at the bottom here, another one somewhere around here, another one here, another one somewhere around here. We'll just bring these over a little bit, just take that down to there. Actually what we'll do is just pull these back so that they're just about on the points there, somewhere there, and then we put another one in here, and finally one here. We can even these out. I mean, we want to go somewhere like 0.2 with that one, 0.4, probably a little bit back, 0.6, somewhere there. You know, it's one of those things where you can just adjust it to your heart's content. But, you know, there's no exact science with it. But, you know, this is the kind of thing you're aiming for. And we could possibly put another one in here. Just bring that down to there. Something like that will be okay, I think. But as I say, you can play around with this and adjust it until you get it exactly the way you want it. But that's the kind of curve you're looking for. A damp sine wave of sorts is what you're looking for. So anyway, we've got that in there, and that should give us a reasonably good shape. So that's our first step complete. We've now got to decide what we want to go in here, and that's where we need our TP geometry. That's going to be our collider, and that's all set up. We don't need to do anything else. Moving on from here, we can hold down the shift key again with our plane selected, and we can add our second deformer, which will be a jiggle deformer. Bring one of those in, just drop it down beneath the collision, and we can think about setting this up. So our strength we will leave at 100%. The stiffness we will make 100%. The structural 40%. And we'll leave the drag at 10%. We don't have to restrict it in any way or use any forces. We're not going to be doing any of that. We don't need to. So we'll leave that as it is. Okay. One thing I do need to do in my collision deformer here, in the advanced tab, just need to check that things are set up in there. So we do want them set up exactly as they are. You can adjust some of these, but the initial settings are actually fine. Okay, so don't worry too much about that. But that's the first two deformers are now pretty much set up. We don't need to worry about those. Again, we'll select the plane, hold down shift, and this time we just need to select a smoothing deformer. So we'll bring one of those in if we can find it. Let's have a look, see where we are with the smoothing. There it is. That's the one we want. And we can drop that at the bottom of the pile there. Let's just see what we've got in here. So in the object tab, a strength of 100 is fine. The type needs to be stretch. I'm going to leave that at stretch, okay? And we can leave everything else set up the way it is. So that's fine. That's all working as it should, because the 10 for the iterations is fine, but these are grayed out now anyway. So if you just leave it on stretch, it should be okay. Right, so that's our deformers set up. Now, What we'll do is bring in our collision deformer into the editor here, and at the input stage we need object properties distance, and we can plumb our ripple size into there, and now we're taking control over how big our ripples are actually going to be. Okay, so if we go into the collision now and go into object, we can see that our distance is now under our control. At the moment it's set to 20 because in our controller we've got the ripple size set to 20. So that is everything complete with regard to the Expresso, and that's the expression. So yeah, there's a fair amount in it, but it's not a particularly complex one again. You know, there's not an awful lot of complexity here, but that's how we go about setting that up. Now let's just see if we're actually getting anything here that works. Let's just run the sequence. Right, we're getting something, aren't we? We're clearly getting our geometry. We can see that we're getting our bubbles, and they are of varying sizes, and they grow on, which is exactly what we want them to do. At the moment though, we're not getting any kind of interaction with our plane, which we should be. So there's obviously something that we need to sort out there. I'm pretty sure the problem lies with the collision deformer. So we'll just take a look in there. Now the colliders here, we've got objects TP geometry, that's fine. The solver, now that still says intersect. What that should be set to is inside stretch. So inside stretch for the solver, and now let's see what happens when we play the timeline. And we can see that we are now getting bubbles. Okay, that's starting to work quite nicely. At the moment they're a little bit small, and there's not much definition here because I used 200 by 200 segments for the flat plane. If you use 400 by 400 you will get better definition, so when you get to your final model make sure you use that. But anyway, for the sake of speed, that's why I've done it, because the animation's running at quite good speed. It does slow it down considerably if you do it 400 by 400. But anyway, let's just switch on the subdivision surface. So we've got that on. Then we'll switch back to, I think, just garage shading for this. And then what we'll do, let's have a look, see where we are. We can go into our controller. And let's make the particle count bigger for a start. Let's go to, say, 40. And we'll make our particle size, I think, around 6. That's a good sweet spot, actually. And the ripple size, let's just make that a little bit bigger as well. Go to about, say, 24. And let's go back to the beginning and see what we get now. Okay, and you can see we're starting to get these nice ripples in there. We're getting some quite sizable sort of bubbles coming out of the thing. And it's all starting to look quite nice. Let's just select the subdivision surface, and we'll go into our basic tab here and select automatic and give this a colour. We'll want a green, so we'll give it something like, let's just go down a bit further. We want a sort of pea greenish sort of colour, somewhere around there I would say will be okay. Right, let's just give this a run and see what we get. And there you go. You can see that this is now behaving like a sort of a cauldron full of something. Could be soup, could be some other concoction, I really don't know. But anyway, you can see that you're getting all these lovely ripples around the bubbles, and it's all working exactly the way we would like it to do. So yeah, that is essentially how you go about doing it. And because you've got the controller, of course, what you can do is set the particle count low if you wish to, so that maybe you build a fire, I don't know, under the cauldron, and initially it might only be producing a few bubbles because the soup might not be very warm, and then as things gradually heat up you could increase this value so that you get more and more particles and more bubbles. And also you could change the size as well. That could be animated, the ripple size, it can all be animated. So, you know, there's plenty of things you can do with regards to the art direction in this particular instance. And quite simple to set up. I mean, as I say, the Expresso, it's not a particularly complex expression really. You know, all we're really interested in here, this is probably the most complex part of it, just grabbing a hold of our data for where the position of each particle actually is, and then saying if it reaches a 0 or above, hold it at that position. That's probably the most complex thing that we're actually doing here. The rest of it is perfectly simple really. But yeah, that's the way you go about creating a bubbling cauldron. And that just about brings us to the end of this tutorial, because that's what I wanted to show you. So as always, I really hope you've enjoyed doing this tutorial, and if you have enjoyed the video, then please give it a like, and if you haven't already, please subscribe to the channel, leave a comment, and of course ring the bell. And wherever you happen to be on social media, then please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, for now, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.